Hello everybody. In this tutorial, I'm going to teach you how to extend from our first video that was done for single variable, but now we will try to do this fmincon minimization for two variables. And the function I'm considering in this case is, suppose it's something like this. It's x squared plus y squared plus 2 times x plus 8 times y. This is the function I'm considering, and we want to find the minimum value of this function. So as you can see, this has now two variables, x and y. Okay, and we want to see how it goes. Okay, so in this case we'll first look at the cost function. So now you see there is no difference in the input variable, it's x. But in the one thing you have to note here is now this x is not a scalar value, but it's rather a vector of two values. Okay, and we can do this two variable minimization by considering x in here, x as x bracket 1 and y as x bracket 2. So what you have to do is you have to write the same equation for the function like this, so you can see the similarity. If you want to make it much more easier, you can consider, for example, a equals x1 and then b equals x2, and then instead of x1 you can put a, and instead of x2 you can put b, and same goes over here. So it makes no difference. So the only difference is you have to know that when you do this two variable minimization, the two variables are here as x1 and x2. Okay, so you can see, considering this function here and here, it's basically the same, but we have changed the names of the variables. But this is and also the constraints in this case, I do not consider any constraints, so it remains as this, right this. And now the initial guess, okay, the initial guess, it needs to be two values because we have both x and y. We need to supply as input two initial guesses for the two variables. So in here I suppose that the initial guess is 4 for x and 7 for y. Now let's run this and see what the output is. So you see it says local minimum found, that satisfies the constraints, and from here you can see the minimum value is minus 17, and it happens when x is minus 1 and y is minus 4. Okay, so let's see, if we suppose we change the let's say the initial guesses, and let's try it again. Okay, so you see the function value minus 17 and minus 1 and minus 4 do not change. That means this is the minimum that we need to find. Okay, so in here we end this two variable minimization, and in the next video I'll extend this much more further and to the much more general case, that is like for multivariable optimization. So you can have as much as you want, and then you can see it's similar to this, so you just have to change some things, that's all. But after that you'll be able to do minimization for multivariables. So if you have not subscribed to my channel, please do it now, and I'll see you in the next video. Thank you.